Imagine you're a mother with a limited supply of food. You, of course, want to feed your children so that they can survive and eventually have children of their own. But what if a child that isn't yours tries to take your limited resources? Would you feed him? Would you sacrifice your own children's fitness to help a parasite? Probably not, and you're not alone. Many species will evolve a keen eye to help avoid feeding parasites. However, this isn't the case with the Cape bulbul and its brood parasite, the Jacobin cuckoo. A brood parasite is an animal that doesn't raise its own offspring and instead uses another species to raise its children. Many species of cuckoo do this by laying their eggs in the nest of hosts. Many birds have the instinct to give food to the baby who yells the loudest or who has the largest mouth. Normally, this ensures that the offspring who is most likely to survive does, but when the brood parasite is twice, 3 times as large as its host, it ensures that the imposter baby gets the most food, and the host's actual babies suffer. The brood parasite will also try to kill off its foster siblings to get more food. So why don't the host parents just kick the parasite out? Some brood parasites, such as 2 subspecies of the Jacobin cuckoo, have evolved so that their eggs mimic the host's. This way, the host is not able to tell if the egg is a parasite and raises it normally. This isn't the case with our Jacobin cuckoo, though. Its eggs are white and big, especially when compared to the bulbul's eggs. Other times, the eggs are simply too large to push out or too thick to crack. If this is the case, the only way of getting rid of the parasite is to abandon the nest and start over. In nature, often, if a parasite evolves a small advantage, the host counters with an adaptation of its own, and both species are locked in an ever-escalating stalemate. This is known as an evolutionary arms race. But other times, the parasite hasn't evolved any traits to make the host accept its egg, and the host hasn't evolved any traits to get rid of the parasites. Which brings us to our topic. Brood parasitism selects for no defense in cuckoo hosts. So why haven't the Jacobin cuckoo and bulbul entered into an evolutionary arms race? Basically, there are 2 hypotheses for why our host birds haven't evolved to eliminate their brood parasites. The first is called evolutionary lag hypothesis. Here, the idea is that the host lacks genetic variation to induce evolutionary defenses, or there has not been enough time for the defense to spread through the host population. The second is known as the evolutionary equilibrium hypothesis. This hypothesis suggests that the cost of parasitism doesn't exceed the cost of rejection. Another way to say this is that it would be more damaging for the host to avoid the parasite than to just accept it. Reproductive success for a bulbul declines significantly as the breeding season continues, so in many cases, it makes more sense to stay with the nest even if they know it has a parasite in it. Oliver Kruger examined and tested these hypotheses through a series of experiments. The first experiment was finding and observing the nest of the Cape bulbuls. Nests were evaluated for clutch size, incubation period, hatching success, and nesting period. The second experiment was an egg discrimination experiment. Unhatched Cape bulbul eggs were collected, and Jacobin cuckoo eggs were made from a plaster mold. The unhatched eggs were either placed in nests as they were found, or painted white to mimic the Jacobin eggs. Eggs were determined as accepted if they lasted 5 days in the nest without any visible signs of the bulbul trying to remove it. With the higher rate of parasitism, the lower the bulbul's fitness was. While it may seem obvious that the higher rates of parasitism would cause lower fitness for the bulbuls, the timing of the cuckoo's egg laying actually played a large part as well. When placed at the correct time, bulbuls lost most of the fitness to the cuckoos. From observation, it was found that the rates of parasitism ranged from 6 to 72% of bulbul nests per year with an average of about 22%. The laying of the cuckoo egg damaged the host eggs 50% of the time. Without parasites, the average number of chicks per clutch was 0.72, and with parasites, it was 0.19. That's 73% fewer chicks. This is not ideal for the bulbul, and it would seem like it would be better to abandon the nest, but the bulbuls rarely rejected the egg. Desertion only occurred when the egg was placed by the cuckoo before the first host egg was laid, and the rates of desertion for the bulbul eggs and plaster cuckoo eggs placed in the nest were not significantly different. Only around 10% of the nests with the fake eggs placed were abandoned. To move to another nest, it would have to be built from the ground up, or branch up, and it would be too costly. Approximately 40% of the cuckoo eggs never even hatch, so abandoning a nest at the first sign of a cuckoo egg could be deserting a perfectly good clutch for nothing. Much of the reason for the decreased fitness of the deserters is because both the rate of predation in black and the rate of parasitism in gray increase as the breeding season continues. While building a nest and laying eggs is manageable energy cost, it takes time that the bulbul can't afford to lose. Imagine going through all that work only to wind up in a worse situation. Ultimately, the eggs of a Jacobin cuckoo are too big and too sturdy for the bulbul to act upon it once the eggs have been laid. Bulbuls simply do not have the equipment necessary to damage or remove the Jacobin egg, and it's too expensive for them to relocate due to limited resources and predator attacks. So it has been concluded that being inactive toward Jacobin cuckoo eggs has the greatest evolutionary advantage given these constraints. This supports the evolutionary equilibrium hypothesis. Stated earlier, this hypothesis suggests that the cost of parasitism doesn't exceed the cost of rejection. So there you have it. It simply doesn't make sense for these two species to enter into an evolutionary arms race, as it would cause a decrease in fitness for both species. The story of these birds doesn't end here, though. It has been suggested that rather than the evolutionary arms race occurring in the nest, it's happening in the sky. But that's a whole nother video. Thanks for watching!